Standard form is another way to write a linear relationship. So we have slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. And we also have standard form, which is ax plus by equals c. So the specifications are a, b, and c are integers, and x and y are on the same side. Now, just like in the slope-intercept form, m and b, or unlike m and b are actual x or y-intercepts and slopes, the a and the b are not a specific thing, like a specific x-intercept or a y-intercept or a slope. However, when you graph, you're going to use x and y intercepts to graph. Standard form comes in handy when you're talking about many word problem situations. So that's why you should be able to graph it and be able to go from one form to another. So find the x and y intercepts of the following equations. So if you think about a graph of a line, just like this line, this right here is called the x-intercept, and this is called the y-intercept. So if you notice the x-intercept, any x-intercept is where y is 0. So an x-intercept is where y equals 0. And a y-intercept is where x equals 0. So you use that fact to find x and y-intercepts. So to find the x-intercept, you're going to set y equal to 0 and solve for x. So if you set y equal to 0, what happens is this is basically gone. This term is gone because negative 3 times 0 just cancels out. So then what you're essentially doing is solving 5x equals negative 15. You're solving that for x if this is gone. So when I solve, I get x equals negative 3. And I'm going to write my x-intercept as an ordered pair. So that ordered pair is going to be negative 3, 0. Now to find the y-intercept, I'm going to set x equal to 0. So essentially what you're doing is you're covering up this part and solving negative 3y equals negative 15. So y equals 5. So your ordered pair is going to be 0, 5. So in the next part, to find the x-intercept, again, you've set y equal to 0. Think about covering up this part and solving 2x equals 4. So if you solve 2x equals 4, x has to be equal to 2. So my ordered pair is going to be positive 2, 0 because it's on the x-axis. And for the y-intercept, I'm going to set x equal to 0. And when I set x equal to 0, I get negative y equals 4, so y equals negative 4. So my ordered pair is 0, negative 4. So to graph using x and y intercepts. So one way you could graph is you could solve for y, but we actually want to practice graphing using x and y intercepts. It really comes in handy later on. So to find the x-intercept, remember I cross off the 3y or set y equal to 0 such that this term cancels out. So I get x equals negative 2, which gives me the ordered pair negative 2, 0. Then if I set x equal to 0, I'm solving 3y equals 12. So y equals 4, so my ordered pair is 0, 4. So now what I'm going to do is I'm going to take negative 2, 0 and 0, 4, and I'm going to connect them and make a line. So this was my x-intercept, this is my y-intercept, and I can connect them to make a line. It's just another way to graph. So for letter D, if I set y equal to 0, then negative x is 4, so x equals negative 4. So my ordered pair is negative 4, 0. And if I set y equal to, or set negative, or x equal to 0, I get y equals 4. So my ordered pair is going to be 0, 4. So I'm going to make a dot at 0, 4, and negative 4, 0, and I'm going to connect. So that's how you graph using x and y intercepts. So graph each of the following horizontal and vertical lines. So one way that you can remember horizontal and vertical line is the mnemonic HOI VUX. So HOI stands for horizontal line, and then has a slope that's 0. That's what the O is. And it's always going to be equation of a line is y equals. Whereas VUX stands for a vertical line, has a slope that's undefined, and it's x equals a number. So if you have to graph y equals 3, it's going to be a horizontal line, so you go up to 3 on the y-axis and make a horizontal line. For the second one, letter B, you go 2 on the x-axis because x equals 2 and makes a vertical line because x equals is always a vertical line. And then C, I'm going to graph y equals 5, so I'm going to go up 5 on the y-axis. 1, 2, 3, 4, 5, make a horizontal line. And y equals 0 is like this. It's on the x-axis. So this is y equals 0 no matter what. X is, y is always 5. No matter what x is, y is always 0. Same over here. No matter what x is, or y is, x is negative 4. And x is 0. The most difficult part maybe of writing in standard form is taking something in slope-intercept or point-slope form and writing it in standard form. So standard form, remember, you have x and y on the same side, and then you need to have a, b, and c all integers. So to be all integers, what you're going to have to do is clear fractions. So first, I'm going to get x over here. Now, sometimes in some textbooks, I see that the value of a has to be positive, and we're going to do that in Algebra 2, but in here I just want you to put x and y on the same side. So if I have x and y on the same side, it's negative 3/4 x plus y equals 2. So in order to write them as integers, what you want to do is clear fractions. So I'm going to multiply this side by 4, multiply this side by 4. Now I picked 4 because that was my denominator. So if I multiply this side by 4, I have to do 4 divided by 4 times negative 3. So that's negative 3x. Plus 4 times y is 4y equals 2 times 4, which is 8. So that's in standard form because all of these coefficients, or both these coefficients and this constant are integers, and then x and y on the same side. Okay, letter B. I need to add 2/5 x to each side. So I have 2/5 x plus y equals 1. Now I need to clear fractions. So I'm going to multiply this side by 5 and this side by 5. Still keeping the equation balanced, so this is going to be 2x plus 5y equals 5. So it's in standard form because x and y are on the same side, and I cleared fractions. These are all integers.